Hello everyone. Today we're going to be starting with the A-level syllabus, and we're going to be starting off with a pretty easy topic. We're going to be doing communication and internet technologies, and we're going to be covering the first part today, which is related to protocols, so TCP and all of that. So initially, let's learn what is a protocol. A protocol is a common standard for communication between the same group of devices. So there are multiple devices in the world. Obviously, we have laptops, iPads, mobile phones, and they all communicate differently with each other, and we need a common standard so they can all work together. And this allows for devices made by different manufacturers to communicate with each other. So I could have a Dell laptop and you could have an Android phone, and that would allow them to combine and communicate with each other without having to be the same device or brand. Finally, all the data that is transmitted between protocol compatible devices must follow a set of rules. So let's unpack this with a very easy example. Imagine I have a person from China, right? And I have someone else from the UK. So, what would be a common mode of communication with them? Most likely English, right? So, everyone knows that. So, that will become a common standard. So, if one person wants to communicate with the other, they must use the same language, for example, English in our case. And this means it allows from different manufacturers or different countries to communicate with each other, right? And it's a common standard for communication. And all transmitted data between compatible devices must follow some set of rules. So if you imagine, if I could create my own set of rules for English, and you had your own set of rules for English, that would decentralize communication. I would understand what you're saying, and you would understand what I'm saying. That's why we developed grammar in English, which must be followed. And this is pretty similar to how you can expect protocols to work. So how do different protocols work together, and how does it allow communication over the internet? So what we can do is we can see protocols as stacks of sorts. So we know a stack in computer science, very simple. It's like it's a 1D array where there are different levels. So like that. Basically an array. And what we can see, we can visualize the internet as a bunch of layers. So our very first thing is each layer is responsible for its own part of communication. So each layer does something specific. One can convert the data into raw signal. One can create and find the most efficient route. Each layer is responsible for its own part of communication. And data, obviously, we know is sent as packets. And data is transferred one by one from top to bottom layer before sending. So if you imagine this diagram here, I have, for example, a smiley face, which I'm sending. This first goes through application layer, transport layer, which will all go over in the next page. They will go over these different layers, each layer doing some of its own function, and then it will be sent over the internet to be received. And each layer has its own specific rules and software which is used to validate it. As you get closer down, it gets more analog, and to the top it's more digital. So software is used in the application transport layer most of the time, and each layer operates independently of each other. So if the transport layer needs to do something, it doesn't need to rely on the application layer. Of course, it needs to rely on the application layer to get the data, but it doesn't apply any calculations or processes that are required in the previous layer or the next layer. Awesome. So now let us go a bit more into depth of the TCP IP protocol. So TCP IP has 4 layers, and this is the key protocol that allows for computers to communicate over the internet and any other network, essentially. So if we see it, the TCP IP model works on the application layer first. It's sent to the transport layer, the internet layer, and now the network access layer. This has many names, but such as the physical layer or the data link layer. However, it's the last layer and it performs all the same tasks. So let us dissect what the application layer does first. As in its name, it's used in the application part. So it's where the user interface is present and the user submits the data. So for example, if you're in Chrome and you enter google.com, This is the application part. And over here, the data is secured by using encryption or whatever other method they may use. And then there's the final part which occurs, which is translation. So data is of course present in many different types and is formatted so it is the same for all TCP IP transmission, right? Awesome. Next we have the transmission layer. So this is where you get into nits and gritty of communication. So firstly we do segmentation where you divide the data into different packets. So if I had something like google.com, I would divide this up into different parts. So this would be one part, this could be one. It's just breaking up your data so it's sent in different packets. And then after that, the order of which the packets are transmitted is added to the packet header. Of course, you guys know a packet has 3 layers. It has the header, it has the payload, and then it has the trailer. So this is from IGCSE knowledge. Payload has our data, header contains some stuff like IP, source, destination. Trailer contains error checking mostly. So we decide the sequence and we add that onto our data. Finally, it receives data from the application layer, which we know, and then sends it to our next layer, which is the network layer or the internet layer. Again, there are multiple names for many of these things. This is basically the core idea of packet switching, which we'll see in another video. And this is when it decides the optimal route through which packets will travel. So if we imagine I have a dot here, I can go from here, here, here. These are all nodes, which we call it. These are all centers which data can travel through. So what it does, it decides, hey, which is the best way for me to go? So I can go from here, 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 or I could consider an alternative path, something like here, here, and then here. So I'll decide, this is based on basically the amount of traffic that's occurring in the network, and it wants to optimize it to reach the fastest place possible, right? And it works with data. This is the network layer or the internet layer is primarily the router's function, and it addresses the packets with their source and destination IP addresses. So it sees, hey, I'm from this computer and I want to go to this computer. Where should I go next? And again, it transmits data between the network access and the physical data link layer. This is the physical. This is when data is being transferred in copper cables, radio waves, right? So data is turned to raw signal, which is analog, and it's transmitted over the network. So all the network all the network tools we use. This is responsible for the rate at which data is transmitted. So obviously everyone has different bandwidths. My router may be faster than your router. So this is what determines it. And it's responsible with the physical connection. So it deals with the real world, It deals with the real world. So if I have my laptop connected through Ethernet, that the data link layer is what's sending the data to and from in the cable. Awesome. So that is the core idea of TCP/IP. This is probably the hardest concept in this part of the chapter. Finally, there's just some other protocols you need to know a decent bit about. So firstly, we have HTTP. I'm sure you guys have heard of this. This is where you send and receive web pages, and the newer version is HTTPS, which is more secure with encryption. And this is basically how web pages are loaded. Next, we have FTP. If any of you guys have worked with online machines, cloud computing, I'm sure you guys have heard of FTP. It's basically the protocol for sending and receiving data. And this is like FileZilla, which is a common FTP server. Now, SMTP, this is used for sending emails from a mail server using the push protocol. And we'll discuss what push and pull protocols are later. POP3, and just for another note, SMT is now the industry standard for email services. POP3 is used for receiving and downloading emails from a mail server, like always, and it uses a pull protocol, which is basically when users need to make a request to see new emails. And on the other hand, push protocol is when the messages are automatically delivered. So if you imagine I'm a medieval traveler, right? I have to go out, I have to go to the town hall to see, hey, have I got a message? That's how the pull protocol works. On the other hand, push protocol is then whenever the town hall receives a message, it automatically sends it to my home. So I don't have to worry about getting it. It will automatically come to me. Next is IMAP, which is another email protocol, and it's used for receiving and downloading emails from mail servers. The only difference between IMAP and POP3 is it automatically deletes your emails after you read them. Finally, one of the most interesting things and examples of mesh networks is BitTorrenting or peer-to-peer. Right, so it's basically a file sharing protocol. I'm sure if you guys have ever downloaded movies online illegally, you would have used BitTorrent or some sort of torrenting software. It's basically when each computer has access to a file. Say this computer has access to John Wick. So does this computer, and so does this computer. Now, I'm over here. I want to download the John Wick movie now. What I can do is if it's a 3-hour movie, I can download the first 1 hour from here. I can download the second 1 hour from here, and then the third 1 hour from here. I can download different pieces of files from different computers, and I can collect them together into one coherent file. So what this does is this reduces transmission time. Of course, it has disadvantages of security, and it doesn't usually lead to reduction because so many computers are connected and wanting the data. And this is used for distributing large files across the internet, as we saw, as it reduces the time taken. This leads to the idea of swarm downloading, which I just discussed. It's when files are broken down into different pieces and they're stored with different users, and they're downloaded and assembled together by a single user again, which will be me over here. So that is the core and crux of the first part of the communication chapter, and I wish you guys the best of luck.